All right, so now we are going to start the section 5.3. And this section 5.3, it's about rational equation, inequality, and model and application. So on this problem number 1, you have the graph of a rational function, and you need to use the graph to find the value of, to solve f of x equals 0, solve f of x less than 0, f of x greater than 0, and use the set of notation. So when I look at f of x equals 0 on that problem number 1, what does that mean, f of x equals 0? It's basically looking for y equals 0. But I can see that y equals 0 on this graph is an horizontal asymptote, meaning that it's a no solution. There is no solution that can allow me to have f of x equals 0 because it's an asymptote. It's an horizontal asymptote, for instance. For B, we are looking for a f of x which is greater than 0. So what I'm looking at, it's mainly looking at for f of x, and actually that's C. So I'm going to do B first, which is less than 0. We are looking at an f of x which is negative. We are looking at all the value of x where f of x is negative, where all the value of y are negative. And so based on my picture, on the graph that I have in front of me, it's going to be between negative infinity and negative 2. Why do I have a parenthesis on the side of negative infinity? It's because it's always a parenthesis. But for negative 2, I have a parenthesis because negative 2, x equal negative 2 is a vertical asymptote, meaning that x equal negative 2 cannot be part of the solution. And finally, for f of x greater than 0, meaning that f of x is positive, all the value of y who are positive, well, based on what I have in front of me, it's going to be negative 2 and plus infinity. All right, so now problem number 5. What do we have on the problem number 5? Same idea. When I look at y equals 0, I end up to have a set of solutions that correspond, so y equals 0 corresponding to f of x equals 0, that the set of solution is x equals 0. That's the only point of intersection between my function f of x and the x-axis where you have y equals 0. Where do we have the function f of x negative? Well, I will have my function f of x negative from negative 2 to 0, union 2 to plus infinity. Okay? And finally, if you look at the function f of x positive, you will see from negative infinity to negative 2, union 0, 2. These are the two set value of x where you will find a value of y positive. After problem number 5, we need to do problem number 8. So problem number 8, it's the same idea, and let me graph the problem number 8 like this. You will have visually the graph in front of you, just in case. All right, so in this problem number 8, we need to repeat exactly the same direction. We need to look at the f of x equals 0, but this time solve f of x less than equal than 0 or greater or equal than 0 for C. So for equal to 0, I can see clearly that right here and right there, we have the two only value. So for A, I'm going to have a set of solution, negative 1, 0. For B, it's going to be negative 2, negative 1, union 0, 1, union 0, 1, union 1, 2. Union 0, 1. So it's going to be, let me repeat that. It's going to be negative 2, negative 1. Why negative 2, negative 1? Because I can see clearly that between x equal negative 2 right here and x equal negative 1 right there, I got a negative value of my function. And then if I look at the rest, I can see that I have a union, and it's going to be 0, 1. So between 0 and 1, between 0 and x equal 1. So somewhere right here, I didn't put it properly, but oh, I know why. I know why, because I have right here at x equal 1, I got a hole in my function. This is a hole, meaning that between 0 and x equal 1, I have a negative value of f of x. And then from union, from 1 to plus infinity, I will have sorry, no plus infinity, to x equal 2. This is x equal 2. So to 1 to x equal 2, I have a x function negative. So let me represent this. I have right here negative, right there, and right here it's negative. And if I look at the positive, for f of x positive, I am going to have negative infinity to negative 2, to negative 1 actually. Actually, it's not, it's negative 2 right here. Right here, it's negative 2. And x equal negative 1 was right here. So I repeat, for f of x is positive from negative infinity to negative 2. Then I am going to have from union from negative 1 to 0. And finally, and 0 part of a set of solution, when negative 1 is also part of the solution because it's on my function. And then I am going to have union from 2, and this time 2 is corresponding to the vertical asymptote, to plus infinity. So if I look at it, I am going to have, let me change the color, and I'm going to take green. This is where it's going to be positive from negative infinity to negative 2 being right here. And then I'm going to have another part which is positive between a negative 1 and x equals 0. And the last part is going to be from negative 2, from plus 2, which is the asymptote, to plus infinity. Okay, guys, so now let's move on to the problem number 19. What do we have on the problem number 19? On this problem number 19, we have 1 plus 3 over x squared over x equal 5 over x squared. 5 over x squared. So the first thing we want to do is calculate the LCD. How to calculate the LCD? You are going to take every single denominator and try to completely factorize into prime every single denominator. So when you look at 1, because it's 1 over 1, so this one right here is this one right there. And so obviously when I completely factorize this into prime, 1 will be 1, x will be x, and x squared will be x squared. And the LCD is the multiplication of each factor with the highest power. In that case, 1 multiplied by x squared. So therefore, I'm going to multiply by x squared both sides of my equation. And the result of multiplying by the LCD both sides, we end up to have x squared plus 3x equal 5, meaning that x squared plus 3x minus 5 equals 0. So A equal 1, B equal 3, and C equal negative 5. You end up to use your quadratic formula, and you end up to have x equal negative 3 plus or minus negative 3 plus or minus the square root of 29 divided by 2. All right, so now problem number, I think is 26 and then 29. So in this problem number 26, we're having f of x equal 1 over x plus 3, 1 over x plus 3, plus 4 over x plus 5, plus 4 over x plus 5 equal 2 over x squared plus 8x plus 15. So you are going to calculate the LCD by completely factorizing to prime each denominator. This is a plus 5, so plus 5. And then x squared plus 8x plus 15. X plus 3 will be x plus 3, x plus 5 will be x plus 5, and x squared plus 8x plus 15, it's going to be x plus 3 by x plus 5. Please check this out just in case. And obviously your LCD is going to be the multiplication of each factor with the highest power, and in that case your LCD is going to be equal to x plus 3 times x plus 5. So if you multiply x plus 3 times x plus 5, both sides, you end up to have multiplied by 1 over x plus 3 plus 4. So plus x plus 3 times x plus 5 times 4 times over x plus 5 equal 2 times x plus 3 times x plus 5 over x squared plus 8x plus 15. Now you can see clearly that x plus 3 is going to divide out. I'm going to use another color much better. X plus 3 divide out, x plus 5 divide out, and finally x squared plus 8x plus 15 will be divided out with x plus 3 times x plus 5. And this is again a plus. So I end up to have at the end of the day an equation looking at x plus 5 plus 4 times x plus 3 equal to, so x plus 5 plus 4x plus 12 equal to, so a 5x plus 17 plus 2, equal to, so 5x equal minus 15, and so x equal minus 3. Number 29, same idea, but the difference with problem number 29 is we end up to have 9x to the negative 1 plus 4x times 6x minus 3 to the negative 1 plus equal 2 times 6x minus 3 to the negative 1. I would like to remind you that a to the negative n equal 1 over a to the n. Therefore, I end up to deal basically with 9 over x plus 4x over 6x minus 3 equal 2 over 6x minus 3. So I will have to multiply by the LCD. I'll let you calculate the LCD, which is going to be x times 6x minus 3. And I end up to have 9 times 6x minus 3 plus 4 times x equal 2 times x. I end up to have a quadratic function, because my quadratic function is going to be 4x squared plus, so 4x squared plus 9 times 6x minus 3 equal 2x. You distribute, you are solving the quadratic equation, and you end up to have one solution, which is x is going to be equal to negative 27 divided by 2. Alright guys, I'm going to do another video for the rest of the problem I gave you. This one is done. There is only 1 minute and 30 seconds, not enough time to move on, and I would like to slow down a little bit. But again, for these problems, what you have to do is multiply 9 by 6x, 9 by negative 3, move everything on one side. You will end up with a quadratic equation. You solve this quadratic equation by making sure you're not making any mistakes, by finding a, b, and c, and you will find by using the quadratic formula that there is only one solution, which is x equal negative 27 divided by 2.